In determinant chapter exercise 4.2, let us do some more problems. Question number 11. Determinant is in first row x plus y plus 2z x y, z y plus z 2x y, z x z plus x plus 2y. You have to prove here this total result after solving using the property 2 times of x plus y plus z whole square. Prove this result. With the help of properties here, to get this result, apply C1 tends to C1 plus C2 plus C3. C1 plus C2 plus C3. This will be added in C1. So you will have in C1 2 times of x plus y plus z, x plus y plus z, 2 times x plus y plus z, and remaining C2 and C3 will be same. Now from C1 you can take 2 times of x plus y plus z common. After taking common, you will have in determinant first column 1 1 1 and second and third are same. Now 2 more factor of x plus y plus z apply here. R2 tends to R2 minus R1 and R3 tends to R3 minus R1. R2 tends to R2 minus R1. Subtracting R1 from R2, then R2 will change. You will get these elements. R3 minus R1. R1 is subtracted from R3. In R3 you will have these elements. Now you can take x plus y plus z common from R2 and x plus y plus z from R3. Means 2 more factors you can take common out of this. You will have x plus y plus z whole cube. Now you can expanding along C1 or any row, any column you can expand. In expansion you will get 1 and your result is 2 times of x plus y plus z whole. This is your result. Now see question number 12. In this question your determinant is 1x x square in first row, x square 1x in second row, and third x square 1 is equal to 1 minus x cube whole square. Here you have to prove this result using property. To getting this result, you can apply here R1 tends to R1 minus x times of R2. R2 tends to R2 minus x times of R3. R1 and R2 will change. In R2 multiplying by x, then subtracting from R1. In R3 multiplying by x, then subtracting from R2. So R1 will change, and in R1 you will have 1 minus x square 0 0, and in R2 0 1 minus x cube 0 when you apply these two, and R3 will be same. Now you can take 1 minus x cube common from R1 and also 1 minus x cube from R2. So 1 minus x cube whole square, there are 2 factors are in common, and within this determinant you will have in R1 1 0 0, R2 0 1 0, and R3 x square 1. Now you can expand it. So after expanding you will get only 1. When you expand along any row or any column, then your result will be 1 minus x cube whole square, which is equal to the right side. Now see one more question. Question number 14. Determinant is in R1 a square plus 1 ab ac, in R2 ab b square plus 1 bc, in R3 AC BC c square plus 1. Now here you have to prove result is this after solving 1 plus a square plus b square plus c square. You have to prove this result. To apply in R1 multiplying by A, in R2 multiplying by B, in R3 multiplying by C. Directly. You are multiplying, so you will have to divide here A in R1, B in R2, C in R3, so A, B, C divided. In R1 A into this A square B, A square C after multiplying by A. In R2 by B, after multiplying you will get AB square B times B square plus 1 B square C, and in R3 multiplying by C, so AC square BC square C times of this. Now remember here, so in row multiplying by A, B and C respectively R1, R2, R3, and A, B, C taking out common from C1, C2 and C3 respectively. A from C1, B from C2, C from C3, taking out common. This is the common factor. After taking common in C1, you will have A square plus 1 B square C square. In C2, A square B square plus 1 C square. In C3, A square B square C square plus 1. Here you have to prove 1 plus A square plus B square plus C square. So for this result, apply R1 times 2 R1 plus R2 plus R3. In R1 adding R2 and R3. Then in R1 you will have, after applying this, 1 plus A square plus B square plus C square in each places, and R2 and R3 will be same. Now after this, 1 plus A square plus B square plus C square taking common. After taking common in R1, you will have 1, 1, 1, and R2 and R3 will be same. Then one more property you can apply to get 0 in this determinant. Applying C1 minus C2, C2 minus C3. Why? Because if 0 comes in many places, so you can easily solve it. So in common factor is here 1 plus A square plus B square plus C square. Then expanding it, after expansion you will get one result, and result will be 1 plus A square plus B square plus C square. This is